Okay, next thing we want to do is we're going to explore the concept of molar mass and counting atoms by weighing atoms. All right. And so we'll do this with an example of, say, nails first, okay? Because sometimes it helps people make sense when you do a tangible object. So some places, and this is less real now, but years ago, you could buy nails by the pound, and in commercial stuff, you can still kind of do that. It's easier than selling them by tens or hundreds or gross or something like that. We want 2.6 pounds of nails. We know that a dozen nails weighs 0.15 pounds. Can you solve this? Let's make sure that you can work this before we move to atoms, okay? So can you solve this problem for me? So if we're solving this problem, what value should I start with? 2.6 pounds. And now I got a conversion factor. What do I use as my conversion factor? A dozen on top and 0.150 pounds on bottom. And then I need another conversion here because I'm trying to get to actual nails, right? So how many nails in a dozen? So pounds cancels, dozens cancel. I'm left with nails. How many nails is it? 208. So this is exactly the same math we're going to use because we're going to see chemical compounds in grams. And we're going to go from grams to moles, and then from moles to atoms. Okay? It's going to work the same way. So again, atoms are tiny. So again, we need a thing like a dozen, but we need something way bigger than a dozen. And our dozen, a chemist dozen, is called the mole. All right? MOL is how we abbreviate that. And again, it's this number. 1 mole of stuff is 6.022 times 10 to the 23. It's just a number. The same way as, how many is a pair? 2. How many is a dozen? 12. How many is a gross? 144. A gross is 144. So we use these numbers all the time, right? We use stand-ins for numbers all the time, right? Pair, dozen, gross. Now we have a new one. Now we have a mole. When we say mole, we mean that number of things, okay? And it can be anything you want it to be. A mole of people would be 6.022 times 10 to the 23 people. That's way more people that have ever lived in the entire universe that we know of, okay? So this is called Avogadro's number. And 1 mole of anything is that number of things. To kind of give you an idea of how big it is. So if these pennies are actually made of copper instead of mostly zinc, about that many pennies would be a mole of copper. Okay? These 2 helium balloons would contain together about a mole of helium. Okay? So we use mole because it's a large macro scale amount of things, right? That's something that we can easily measure, we can easily weigh. We define it as 12 grams of carbon 12, right? The number of atoms in 12 grams of carbon 12 is how we define a mole. Why 12 grams of carbon 12? Again, that's about a handful of charcoal. So with this relationship of atoms to moles, now we just need a relationship between moles and weight. But we have that on the periodic table. On the periodic table, we have all those decimal numbers, that atomic mass that we just talked about. Problem with that is that's the weight of 1 atom. We would like to have the weight of a mole of atoms because that's the thing that we've got right here is mole. So lucky for us, that number on the periodic table can mean the weight of 1 atom in atomic mass units, or it can mean the weight of a mole of atoms in grams. So that number on the periodic table also works for how many grams is a mole of that stuff. So let's go step at a time. Let's make sure we can do this conversion first. So this is like the dozen to nails conversion, right? It works the same fashion. So 3.5 moles of helium to atoms of helium. How would we make that conversion? So we'd start with our 3.5 moles because that's the only number given. And now we need a relationship between moles and atoms. And what is that relationship again? You guys tell me. Avogadro's number is right. Where does it go? Where does moles go? And how many moles? 1 mole on bottom. And then up here, 6.022 times 10 to the 23. We're dealing with atoms here, so we'll say atoms. I just ballparked that in my head. Is that what you guys get? Fantastic. Look at me go. So again, your conversion factor is here. Avogadro's number is the number of atoms in a mole. Okay? Make sure we can go the other direction too. Can we convert atoms of silver into moles of silver? What's the difference between this problem and the last problem? It's backwards, right? We're doing the opposite thing. So what does that mean for your conversion factor then? You're going to flip it. Yep, conversion factor will be flipped. So here we'll start with 1.1 times 10 to the 22 silver atoms. Our conversion factor is going to need moles on top this time because that's what we're trying to get to. So 1 mole of silver is how many atoms of silver? That number. What is that number? That's the number we're going to ask you to remember. That's right. We don't ask you to remember a lot of numbers in this class. I'll usually give them to you. This is one you're going to remember, okay? Because you're going to use it all the time. So now we got 1.1 times 10 to the 22 divided by 6.022 times 10 to the 23. So I simplified 10 to the 22 divided by 10 to the 23 is 10 to the minus 1. So you got 1.1 divided by 6.022 times 10 to the minus 1. So what do we get here? 0.017 or something like that? 0.018 moles silver. So to ballpark that in my head, I went, well, that's a sixth, right? 1.1 over 6.022 is roughly a sixth. So what is a sixth? Well, a third is 0.33. A sixth would be half of that. So that's about 0.17, 0.18, right? But then it's got the 10 to the minus 1, so that moves the decimal place one place, so 0.018. So here we can see it laid out. 1.1 times 10 to the minus 22 divided by 6.022 gives us 1.8 times 10 to the minus 2, or 0.018. This is one of the most common things that you'll do in chemistry, this conversion. The conversion from grams to moles that we're going to look at next is the most common. That is the most common thing you'll ever do in chemistry, but this is very close to that. Okay, this is a very common thing, being able to convert between atoms and moles, or molecules and moles, or whatever the thing is and moles, using the 6.022 times 10 to the 23. Okay, seems trivial, but it's really important because it gets used all the time. All right, we're going to ask you to solve this one here. Okay, so 3.01 times 10 to the 23 atoms. 1 mole is 6.022 times 10 to the 23. Good news is the times 10 to the 23 cancels, and I've got 3.01 divided by 6.02, and that's a half, right? Okay, so back to our hardware store. Different nails weigh different amounts, right? So if I got a dozen big nails, they're going to weigh different than a dozen small nails. And so we have to have this relationship between weights and amounts for all the things. And we have to do that for atoms as well. For example, a mole of sulfur weighs 32.07 grams. A mole of carbon weighs 12.01 grams. We have all those relationships. All those relationships are tabulated for us. They're given to you on the periodic table. That's what the number on the periodic table means. When you look up carbon on the periodic table, you see 2 numbers there. You see a 6. That tells you how many protons it has. You see 12.01. That can mean either the mass of an atom in atomic mass units or the mass of a mole in grams. Okay? We almost always will use the grams per mole relationship in this class because nobody cares about how much one atom is going to do. Okay? We always work in scale of moles in chemistry. So those numbers on the periodic table are your gram to mole relationship for every atom. So if we looked up copper on the periodic table, we would see 63.55. Again, what that means, 1 atom of copper weighs 63.55 AMU on average, right? Because it's different isotopes. 1 mole of copper, though, is going to weigh 63.55 grams. So we write that in this fashion. That number we pull off the periodic table is written in a fractional form, and we say it's that many grams per mole, okay? That is a conversion factor between grams of that particular atom and mole. The simplest way I can define that relationship that we were just talking about is that, right? An atomic mass unit is the same as a gram per mole. So just to drive it home here, if we looked up lithium on the periodic table, we would see this number, 6.94. What that means is 6.94 grams of lithium is the same as 1 mole of lithium. And using Avogadro's number, we know that that means 6.94 grams of lithium is 6.022 times 10 to the 23 lithium atoms. Okay? Now we can do relationships where we can start with grams, we can end with atoms. Or we can go the other direction, right? We can start with atoms, we can end with grams. So if we wanted to find out how many moles of sulfur is that, we would start with our 57.8 grams of sulfur. We would go to the periodic table, and we would find sulfur on the periodic table, number 18, I think 16, number 16. And we would find the number on the periodic table, 32.07. That means this right here, that 32.07 grams of sulfur is the same as 1 mole of sulfur. That's what the number tells us on the periodic table. We use that as a conversion factor. We write the conversion factor. 1 mole of sulfur is 32.07 grams of sulfur right here. We write it in such a way that grams are on the bottom and cancel out. We're left with moles. So 57.8 divided by 32.07 gives us 1.8 moles of sulfur. We can do this for everything on the periodic table. There's a relationship like this for everything on the periodic table. We can take it the other direction. If we can start with moles and go to grams. 6.73 moles of aluminum. We want to know how many grams is that. We need the relationship between grams and moles. That relationship comes from the periodic table. I'm going to say that 1,000 times before the day's over. The relationship between grams and moles comes from the periodic table. Go to the periodic table, find aluminum. Aluminum is number what on the periodic table? So go to periodic table, find aluminum, it's number 13. The other number that's there is 2698. What that means is there's 2698 grams of aluminum and 1 mole of aluminum. That is our conversion factor. That's our relationship that we use. In this case, we're going to write it with grams on top, moles on bottom, so that moles will cancel. And we can convert to grams. Does everybody understand where the gram to mole relationship comes from? Where does it come from? Say it out loud. Periodic table. We go to the periodic table. That gives me the gram to mole relationship. What about the mole to atom relationship? Where does that come from? Avogadro's number. That's static, right? That's 6.022 times 10 to the 23. So now we can count atoms by weighing them, right? We weigh it out. We use the periodic table to convert grams to moles. We use Avogadro's number to convert moles to atoms. And now we have a direct relationship between grams and atoms. Again, most of the time in chemistry, we're not really concerned with the number of atoms that are there. We look at it in a larger scale. We look at it in the mole scale, okay? So we're going to do everything from the point of view of moles, most everything from the point of view of moles in this class, okay? So this is going to be the most common thing that you do in all of chemistry, no matter what chemistry it is. General chemistry, organic chemistry, physical chemistry, doesn't matter. Grams to moles is the thing that is the most common calculation that gets made, okay? You've learned the most common trick in chemistry today if you've never seen it before. And again, just to prove a point, we can go all the way through, right? We can go from grams to moles to atoms, right? So 16.2 grams of aluminum. How many atoms is that? Well, again, we go to the periodic table. We look up aluminum. We see that it's 26.98 grams of aluminum in a mole. And then we would use Avogadro's number to convert the moles to atoms. So you can see it laid out down here at the bottom. Start with grams of aluminum. use that molar mass. By the way, you'll see me write that in this fashion. I'll write an M that's capitalized with a little tail on it. This means molar mass, okay? Your book will probably use a script M for that, all right? So when I write that, that means go to the periodic table and find that 26.98 grams for 1 mole, right? All right, so we've done that. We've gotten this conversion. Now if we want to go to atoms, we use Avogadro's number. We can get rid of moles multiplying by 6.022 times 10 to the 23. And so we can see 16.2 grams of aluminum is just a little bit more than half a mole. All right, so you solve this one for me. Oh yeah, we should see how we did here, I guess, right?